This is the notes for dilation. Hopefully the pictures look familiar to you because we're going to use the idea of scale factor. Okay. So in my definition, it says the similarity transformations produce similar figures. The image of a figure under my similarity transformation, such as a dilation, has the same shape as the original, but may be different in size. So as you'll notice, my triangle stayed a triangle, my quadrilateral stayed a quadrilateral, but either got bigger or it got smaller. Okay. It can also be a sequence, meaning that I'm doing a reflection where I flip it over, or I did a rotation, I spun on its side, or a translation, and then I do my dilation at the end. Okay. My dilation, though, means that it's either enlarging or reducing my figure. Maybe put a box around this. We've already heard of it. It's called scale factor. So today is hopefully nothing new. Dilation means the same thing as scale factor. Okay. Also a reminder, if it's greater than 1, that means it will be enlarged. It'll get bigger. But if the scale factor is less than 1, then it'll reduce and get smaller. In my similar figures, the corresponding angles are equal. So this angle down here equals this angle equals this angle, but it's going to get bigger or smaller when I get done, leaving me with the ratio of the sides being equivalent. So this side length no longer equals that side length, it's the ratio of the sides that are equivalent. So let's go ahead and fill that part in. So what's true about the angles in the dilation? The angles stay the same. Hopefully we're getting the hang of that part by now. Okay. What's different today, though, is now my side lengths have either gotten enlarged or they have gotten reduced. Okay, so if you want to write that in our own words, we could say enlarged means it got bigger, or reduced means it got smaller. Okay. However, my dilation will always create a similar figure. My angles have stayed the same, so it's still a quadrilateral or it's still a triangle. However, it simply got bigger or smaller. Okay. So now let's go ahead and try our example. We have a picture down here where it says the scale factor between 0 and 1 will make it smaller, or a scale factor greater than 1 will make it bigger. And what we're going to do is take the x and the y both times by that same number. So to find my scale factor, I can't count these side lengths, so let's go ahead and look at the ordered pairs. So for example, my ordered pair for A is at 1, 2, and then up 1. My new A, remember that's my image, as I went over A with a little apostrophe, that one is at 6, 3. So from right there, I can find out my scale factor. Both the x and the y got times by 3. It got larger, so we took that times 3. If I was to make it smaller, remember that would be going this way, then we would take it times 1/3. Okay, but I did make it bigger from A to A1, so that's why we're saying times 3. If you'd like to double check, let's make sure from B and C that that same rule works. So in B, we're at 5, 1. And then the new B is all the way over at 15, and then up to 3. Likewise, C is originally at 1, 2, 3, and then up 1, 2, 3, 4, 5, 6. And the new C is over at 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoop, and then we gotta go all the way up to 18. So my new C is at 9, 18. And yes, that confirms it. From 5 to 15, we took it times 3. From 1 to 3, we took it times 3. From 3 to 9, times 3. From 6 to 18, times 3. So my rule for dilation was 3 times the x and 3 times the y. My shape got 3 times as big, but the angles here stayed the same, so that results in similar figures.